So I have a little clarification to give you on one problem, and then I'm going to work another problem which you may find similar to one of the assigned problems. If you've already got the assignment done, then maybe there's nothing here for you. But in case you have a couple you're working on, one of the problems leads you to this integral, x sine x from a to b, where from the problem you can tell the values of a and b. I'm going to let you figure them out. And I just want to talk about a couple of things about this function, x sine x. First of all, remember in this chapter we've been focusing on finding the right integral. That's what Calc 2 is doing for us. And once we find the right integral, then we can use what we learned from Calc 1 to evaluate it, and we've also added in using our calculators. And it's pretty much up to you, with the understanding that the calculator won't be an option on the exam, and I'm going to keep the arithmetic straightforward. So we do need to think about antiderivatives, just in case of for the problems we'll see on the exam. And the problem here is that x sine x, while it does have an antiderivative and it's not a terribly complicated one, we don't know it yet. So based on where we are now in early Calc 2, we don't know this antiderivative. So, and some of you may have learned it if you had high school AP calculus, but I certainly don't assume that you know it and that you're not. Therefore, just use your calculator. And because sine is involved, there's one thing you have to be careful of, and that is it must be in radian measure. The calculus that we've learned about the trig functions is only true when we measure angles in radians. It's not true. The derivative of sine is not cosine if we measure in degrees. So make sure your calculators are set up for radian measure. If you're in physics, you probably use degree mode there. So you'll need to learn to switch it back and forth depending upon the subject you're working on. Okay, so, if you remember the technique from your high school AP calculus, you can use it here, but I'm not expecting you to. I'm expecting us to think, well, we haven't learned how to get antiderivative of the function x sine x. And we will. It's in the very next chapter, the very first section of the next chapter. So it's not too far away, but we don't know it today, and your assignment's due on Monday. So use your calculator and make sure it's set up in radian measure. All right, let's pause this and I'll go to the next problem. So here is a problem similar to one of the homework problems. At least the things you have to deal with are present in one of the homework problems. So let's see. Find the volume when the area under this function 2 minus the absolute value of x minus 4 is rotated about the y-axis. So this function, if you remember from Calculus 1, the absolute value function is a V-shaped vertex at the origin. When the x minus 4 shifts it over here 4 units to the right, the minus sign flips it over, so it's going down, no longer a V, but an opposite, and then lift it up 2 units and push the vertex at the point 4, 2. And you can probably find these x-intercepts, which will be important values for us, because we want to take all the area under it, which would mean above the x-axis. You can probably find those by inspection. You can also write an equation. I'll show you how it goes. We don't work with absolute values all that often. So we need the function, there it is, to be 0, which means we need the absolute value of x minus 4 to be 2. Add the x absolute value across. There are 2 numbers whose absolute value is 2, and that is plus or minus 2. And now add 4. So 4 plus or minus 2, and if you take those one at a time, 4 plus 2 is 6, 4 minus 2 is 2. And you can see those are the points I've labeled in the graph. Okay, the other trick here especially if we're not going to use our calculators, and we suppose we don't have to. These are lines, but antiderivatives will not present a problem. But they're different lines. Okay, the line over here is. Well, let me show you how to do this. The absolute value of x minus 4, the way we define the absolute value function in Calc 1, and the way you did it in your pre-calculus classes as well. The absolute value number is the number itself. If that number is positive, well, x minus 4 is going to be positive provided x is bigger than or equal to 4. And it's the opposite of that number. Just like we said down here, the absolute value of 2, one of them was negative 2. So the opposite of x minus 4 is 4 minus x. And that's going to be true whenever x minus 4 is negative, which happens for x is less than 4. So even though our function f marks the top of this, because of the nature of the absolute value, to work it out by the fundamental theorem, we actually have to use two integrals. Let me write one integral, and then we'll break it apart. So we're describing the area with functions of x, but we're rotating about the y-axis, so that means we're going to use our shell formula. So using our formula, we get the constant, 2 pi. Let me do it in black. The integral from a to b, let me write the formula. We get our radius factor, which is just x because it's going around the y-axis. And then we get the height of the shells. There's the formula. And for this problem, we can say a, our region goes from 2 to 6. Get an x, and our function is underlined in green up there. So 2 minus the absolute value of x minus 4 dx. So there's an integral that has the right value. But now we need to evaluate it. The instructions are, I've encouraged you to always read the instructions. We want to find the volume, not find an integral, so we have a little more work to do. And the question is, how do we find the value of this integral? There are two ways we can do it. We can do it by a calculator, or we can do it by hand. The calculator version, I'll show it to you. You ought to do it both ways. Make sure you get the right answer both ways, the same answer. So how do we do absolute value on our calculators? Unfortunately, we don't use the algebraic symbol, the vertical bars. Instead, the function has a name, and the name is ABS, a nice name for it. And we put our x minus 4 inside, a parentheses match, and we'll put our dx. So that ought to do the job, and your calculator can handle that absolute value just fine. If we want to use the fundamental theorem, and it's probably good for us to talk about it, then it's just a tiny little bit tricky, because even though the function here, let me identify it in red, this TP-shaped thing, even though that's one single function, our function, f of x, underlined in green up above, in order to write it out algebraically, I have to break it into two parts. You can see we have a line with positive slope on the left-hand side and then a line with negative slope. And those lines are given by this, well, almost, by this form right here. And so by the fundamental theorem, it'll take two integrals because the function on the top changes from this line with positive slope to one with negative. They both will have a 2 pi out in front. Let's factor it out. And then the first integral, I'm going to go from 2 to 4. And then I get my radius factor, x. And then I get 2 minus the absolute value, but x is less than 4. So we're on the bottom branch. The absolute value was 4 minus x. Back to black. Okay, plus, and we're factoring out the constant. So we'll be sure and put a parenthesis at the end. And then we go from 4 to 6, our radius factor x. And then our function factor, which is 2 minus the absolute value. On this interval, x is bigger than 4, so we'll take the top branch. Be careful with parentheses here, they're necessary. Okay, and those we can evaluate. The absolute value symbol has been eliminated. And now I can simplify these, and I won't evaluate them, but I'll write them in so that it's super easy to evaluate them. So we have 2 pi times the whole thing. We're going to go from 2 to 4 on the first one. And I get x times, if you look closely here, you can see a plus x and a minus 2. And then we get the integral from 4 to 6. We get our x factor here. And then we get, and you look closely here, it looks like we get 6. We get minus minus 4, which makes plus 4, and then 2 more, and then minus x. Can't decide which color to use. And then, so 1 more, and then we'll call it good. And I'll let you evaluate it. Of course, this is not the actual problem. 2 pi times the whole thing. And then we'll go 2 to 4, and our function now is x squared minus 2x. Plus the integral from 4 to 6, 6x minus x squared. And now you're ready to go. Evaluate it. All right. I'll be in touch later. Good luck with your homework.